In this video, I'm going to work through several examples where you need to solve a system of equations using substitution. Substitution is the best method to use when one of the equations is either already solved for the one of the variables, or when one of the equations has a variable with a coefficient of 1. For example, in this first problem, we have 5x plus 9y equals 16, and x plus 2y equals 4. And I notice that in this second equation, the x has a coefficient of 1. And the reason I say that is it just makes it a little bit easier and less messy if you have that coefficient of 1. And so the first thing you want to do, and I've color coded these, the first equation is in blue and the second equation is in red. And since the x has a coefficient of 1, what I'm going to do is, to use substitution, I'm going to solve this equation for x. Okay, so I'm going to solve for x. So when I do that, I have the x plus 2y equals 4. I'm going to subtract 2y from either side so that I have, and it's the same equation, just solved for a variable, is x equals 4 minus 2y. Okay, so this is the result that I get when I solve for x in the second equation. So then I'm going to take this equation and I'm going to substitute it into the other equation. That's why this particular method is called substitution. Okay, so in place of x, I'm going to put 4 minus 2y. So I would have 5 times, and I'm going to remove the x, and in its place, I'm going to put 4 minus 2y. And then I still have plus 9y equals 16. From there, I have a good old basic equation, and I need to do the algebra. So I'm going to distribute the 5. So 5 times 4 is 20. 5 times minus 2y is minus 10y. Plus 9y equals 16. I can do a little bit of simplification there on the left-hand side by combining like terms. I have negative 10y plus 9y. So I have 20 minus 1y equals 16. And I'm trying to solve for y. So I'm going to subtract 20 from either side. So I have negative y equals negative 4. I then need to get rid of the negative. So I'm going to divide both sides by negative 1. And I find that y equals positive 4. Okay, once I find that y equals positive 4, then I have to back substitute or backtrack. I'm going to take y equals 4, go back to the equation that I had, solve for x, or I can go back to the original. It's probably better to go back to the original in case I made a mistake. I'm going to go back right here. So I call it back substitute. Okay, so I would have x equals 4 minus 2, and the y value is 4. So I have x equals 4 minus 8. So x is negative 4. Now, typically, because you have two variables, this answer would be expressed as an ordered pair. So as an ordered pairs are written x, comma, y. So we would have -4, 4. And I can verify that this is the answer by taking that ordered pair and substituting it back into the original two equations. So if I take the first equation, I have 5 times -4 plus 9 times 4 equals 16. So I would have -20 plus 36. That does give me 16 equals 16. It's a true statement. Then I do the red equation, checking myself. I have -4 plus 2 times 4 equals, and I don't recall what that is. Let me go back up here and look. Equals 4. So I have -4 plus 8 equals 4. 4 does equal 4. It checks. So I know without a doubt that the solution to the system is -4, 4. This is your solution. Now, you're not required to check it as I did, but that's a good way to do it because then you are assured that you have the correct answer. Okay, so then let's skip on down to the next one. I have 4x plus 2y equals -10, and 3x plus 9y equals 0. Well, one thing I noticed about these, none of the coefficients are 1, but I do realize that 4 is a multiple of 2 and 9 is a multiple of 3. So I have some leeway there, and if I do it right, I can probably avoid having fractions. Okay, so again, I have them color-coded. You can choose whichever one you want to solve. Okay, with lots of practice, you can probably get a better sense of which one you might want to do. And you can also solve for either X or Y. It doesn't matter. Okay, so let's say, for example, I'm going to take the first one, the blue one, and I'm going to solve it for Y. Okay, it doesn't matter which one you do. Okay, so I'm going to solve for Y. That really has to be your first decision, and that may be the most challenging decision. Okay, so I want to solve for Y. So I have 4x plus 2y equals -10. I'm going to subtract 4x from either side because I'm trying to solve for y. So I'm trying to get y by itself. So I have 2y equals -4x minus 10. And then I need to divide everything by 2. So y equals -2x minus 5. Okay, so I have my first equation solved for y. I'm then going to take that equation and I'm going to substitute it into the other original equation. Wherever there's a y, I'm going to replace it with the -2x minus 5. So I would have 3x plus 9 times, and in place of y, I'm going to put -2x minus 5. It's just like a substitution. You substitute the equivalent, like a substitute teacher comes in place of the regular teacher, and that does equal 0. So then I have a basic algebra equation that I need to solve for x in this case. Okay, so I have 3x, distribute the 9, 9 times negative 2x is negative 18x. 9 times minus 5, or negative 5, is negative 45, and that equals 0. Then I'm going to combine like terms on the left side. 3x minus 18x is negative 15x minus 45, and that equals 0. Okay, again, I'm still trying to solve for x here, so I'm going to add 45 to either side. So I have negative 15x equals 45. I then need to divide both sides by negative 15. So I have x equals negative 3. And then we're going to do the back substitution. Now again, it's probably better if you go back to the original equation. I'm going to take it right back up here to where we have it solved for y and do the substitution. So I would have y equals negative 2 times, and in place of the x, we're going to put the negative 3. So then I do the math. Okay, so if I do the math, we would have y equals negative 2 times negative 3 is 6 minus 5, and 6 minus 5 is 1. So I find that y equals 1. Okay, so written as an ordered pair, my answer would be negative 3, positive 1. And again, I have a safety net because I can check myself. If I take and I substitute, okay, into the original problem, I would have 4 times negative 3 plus 2 times 1 equals negative 10. So I have negative 12 plus 2 equals negative 10. Negative 10 equals negative 10. It's a true statement. So I know that it works for that equation. Then I have to do it for the other one. Okay? I would have 3 times negative 3 plus 9 times 1, and that should be 0. I have negative 9 plus 9, 0 equals 0. It is a true statement. So there again, I know that I have the correct answer. Okay, one more. Okay, I have 2x plus 4y equals negative 3.8, and 9x minus 5y equals 1.3. Again, I have them color-coded. The other challenge that I have here is, again, I noticed that I don't have I don't have one of the equations with a coefficient of 1 on the variable. I do, however, notice that 4 is a multiple of 2, but it's not, 5 is not a multiple of 9. So if I use this second equation, it might get messy. So I am going to take this first one and solve. I think I'm going to solve for x this time. Again, this is where you have to make a decision for yourself about which one you want to solve for. And sometimes there are better options than others. Okay, so we would have 2x plus 4y. Oh, I'm sorry. Let me backtrack. I just caught myself because I don't want to have to deal with fractions. Okay, so let's solve for y. If I solve for x, I was going to wind up with a bunch of fractions. Okay, so I have 2x plus 4y equals negative 3.8. To solve for y, that means I want to get y by itself. So I'm going to subtract 2x from either side, and I realize I've just messed up again. I'm going to wind up, I start solving that, I'm going to get a bunch of fractions. So if you realize you're going to get fractions, you might want to rethink it. So I'm going to rethink it here again. Okay, and I'm going to get it right this time. Okay, so I'm going to solve for x. Okay, so 2x plus 4y equals negative 3.8. Okay, I'm going to subtract 4y from either side. So I have 2x equals negative 4y minus 3.8. I'm going to divide everything by 2. So I have x equals negative 2y minus 1.9. Okay, so I have the equation, solve for x. I don't have any fractions, so that's nice because I definitely don't want to mix fractions and decimals together. So then we're going to substitute into the second equation in place of x. So if I do that, I have 9 times, and in place of x, I put negative 2y minus 1.9 minus 5y equals 1.3. And then I have a good old basic equation that I need to solve for y. And the first thing I'm going to do is I'm going to distribute the 9. Okay, so we would have 9 times negative 2y is negative 18y. 9 times negative 1.9 is minus 17.1 minus 5y equals 1.3. Then on the left-hand side, we're going to combine like terms. Negative 18y minus 5y is negative 23y minus 17.1, and that equals 1.3. I then need to add 17.1 to either side. So I have negative 20, whoops. I'm going to add 17.1 to either side. So I have negative 23y equals 18.4. And then finally, I'm going to divide both sides by negative 23. So y equals 18.4 divided by negative 23 is going to be negative 8/10. Okay, once I have it solved for y, we back substitute to find x. So I would have x equals negative 2 times negative 0.8 because x is negative 8/10. So 2 times negative 8/10 is negative and a negative make a positive. So you got 1.6 minus 1.9. So x is negative 3/10. And again, you could take the time to check that. Written as an ordered pair, your solution would be -3/10, comma, -8/10.